Okay guys, welcome to another segment of Not Failing Calculus with LJ. Today we will be discussing limits and L'Hopital's rules. So limits is actually a key factor for calculus, considering we do most of our actual equations based off of limits and how they function. And the basic definition of a limit is the value of a function or sequence that it approaches. So basically, I'll give you guys a graph right here. Okay, so let's say you have this graph right here. Okay, this is 1, this is -1, and this is 1 right here. So let's say you have this function right there, right? So this function right here, and let's say this will be our function, the limit as x approaches 1 of x minus 1 over x minus 1, right? So if we were to plug this in, and remember your proper annotations, never remove the limit until you've actually solved it. So it'd be 1 minus 1 over 1 minus 1, which equals 0. Okay, so in this case, our limit would be undefined. Okay, so from that, this will be our function right here. Okay, so as it says, from x approaches 1, which is here 1, as we look up here in our limit right here, it's currently not continuous because we have a hole here, and so with this, as we can see, as it approaches from the left, this is our limit itself, and it would go from numbers but never actually touching that actual value. So it would go from 0.9, then it would go from 0.99, 0.999, and so on and so forth until it gets the closest it can get to the value without actually being that value itself. Okay, so today we're just going to learn, now that we have a basic concept of what a limit is, we are going to learn how to solve these limits algebraically. So I'll give you guys an example. Example 1 is the limit as x approaches 3 of 5x over x. Okay, so the first thing about solving a limit algebraically, you always want to try to use substitution. In that case right here, all we have to do is plug in the 3 into our x's. So it'd be 3 over 3. Okay, so after plugging them in, you get 15 over 3. Simplify that, and you just get 5. And your limit as x approaches 3 is 5. Okay, so that's one of our most basic ones, in which all you have to do is just substitute it. Okay, and in most of the times with equations like this, all you have to do is substitute it. But there are others in which you would have more complicated. Okay, so with the other one, that was pretty easy because all you had to do is pretty much just substitute it. However, you will most likely come across in calculus functions where your x approaches infinity. In most cases like this, you would either get a finite number, or you would actually just get an undefined number, such as infinity. And when you do come across numbers like that, you will most likely have to put does not exist because it is unbounded. Therefore, you cannot approximate as to which the limit will be. Okay, for example, we'll have 5 minus 7 over x squared. So first step is always to substitute it, okay, over infinity. So 5 minus 7 over, okay, so over here, if we just keep going on and on solving this equation, we would just end up having 5, okay? So that was easy enough, you know, not too difficult. Then we'll have but however, we will come across, let's go, example 3. I'll just give you guys an example of what it would be like to have one where it would actually just be infinity or undefined. So limit as x approaches infinity again. And this would be 2x plus 5 over x plus 1. Okay? So if we do this, okay, so if you plug in the infinities, plus 5 over infinity plus 1. Of course, it's going to be infinity over infinity, but which would make it undefined or does not exist because it's unbounded. However, in cases like this, you could actually take further steps into it. So you could, because even though it does say initially it's infinity, you want to use as many steps as you can to make sure that you actually have a finite number in which the limit approaches. So for example here, you could do many steps such as like factoring or multiplying by the reciprocal or anything like that, as long as you can just simplify it as much. So in this case, I will just divide our numerator and denominator by x's in order to get rid of all our x's in here. See? So we simplify it more and you end up getting 2 plus 5 over x over 1 over x. Okay, so fair enough, guys. So limit as x approaches infinity again. Okay, so the next step is, okay, so after doing that, we just plug in our infinity again. So 2 plus 5 over infinity over 1 over infinity. Okay, so after plugging this in, this would actually give us a 0, and so would this. And then in the end, oh, forgot to do this. 1 plus 1 plus. Sorry about that, guys. And then this would just give us a 2. So therefore, our limit as x approaches infinity of 2x plus 5 over x plus 1 does not give us an undefined or unbounded value. It actually gives us 2. For most of the cases, you're going to have to use some form of rules and such. For this one, you could actually also have used the L'Hopital's rule. And for L'Hopital's rule, you could, in this case, for L'Hopital's rule, all you have to do is, let me write it down, L'Hopital's rule. Okay. For L'Hopital's rule, it is when you have the limit as x approaches infinity, the derivative of f of x over g of x, or basically the derivative of your numerator and your numerator and your denominator. Okay, so when I say I'm talking about taking the derivative, for example, you have 2x squared. So here what you do is you multiply the exponent to your coefficient, which is 4x, keep it the same, and then you just subtract 1, which is just there, or just 4x, right? Okay, so that's pretty much what taking the derivative is. You should remember this from your basic calculus, from your basic introductionary to calculus, but that's pretty much what it is. So for let's go tackle the same example. So we'll just call it example 4. So solve for the limit of as x approaches infinity of 2x plus 5 over x plus 1 using L'Hopital's rule. Okay, so in this case, let's write it down again. Remember, use your proper annotations or you're going to get marked off. Learned that the hard way with Miss Biza. Thanks for teaching me. Okay, anyways, if we would plug this in, we would get infinity over infinity. Oh, quick rule, by the way. You can only use L'Hopital's rule if you're after substitution and your function turns out to be infinity over infinity. If it does not, for example, you had the limit as x approaches infinity from 2 over 5x, then you plug that in, right? X is infinity, 2 over infinity, right? That's not an infinity over infinity. Therefore, you cannot use L'Hopital's rule. Well, in this case, you can. Okay? So we just have to find the derivative. Remember, you should put annotations. You do not want to lose points. Okay, so the derivative of 2x is just 2. Derivative of 5 is just nothing. And then over 1. So your limit is actually 2. Just like from this one that we did, your limit is still 2. Okay? Okay, let's take another question right here. Okay. So we'll do another easier question right here. For the last example, we'll have, this will be example 5. Okay, so we'll use the limit as x approaches infinity of x squared minus 4 over 2 plus x minus 4x. This was actually a released AP question from the 2014 calculus AP BC test. And then for here, so you could either solve it you could either solve it through substitution or some other function, or we could solve it through L'Hopital's rule. However, we have to see if it is if it meets the criteria. Okay, so let's first so let's first use substitution. So infinity squared minus 4, okay, 2 plus infinity, subtract by infinity. Okay, there you go, guys. Okay, that still gives us infinity over infinity, correct? Okay, as we keep going on, at this point you could either just use L'Hopital's rule or just do it algebraically. But remember, you'll need a very strong algebra to be able to do some of these things. And I just suggest using L'Hopital's rule because it's easier and it's faster. So let's just do L'Hopital's rule. Okay, so limit as x approaches infinity of x squared minus 4 over 2 plus x minus 4x. Okay, since it meets it, let's find the derivative of it. Okay, so the derivative of x squared is 2x. Derivative of 4, 0. Derivative of 2, it's still 0. Derivative of 1 is 1. And then the derivative of 4x squared, that's just 8x. Okay, guys. Let's see. Now, for right now, let's just plug it in again. It's perfectly fine to use L'Hopital's rule again and again and again, as long as it still meets the criteria where your limit ends up being infinity over infinity, right? Okay. So for this one, it's still infinity over infinity, so you can still use it again. But as you keep going, you'll come to realize that you will have a finite because there's only so many x's that you can have, you know. So 2x minus 1 minus 8x. Let's find the derivative of that. Okay, so that would be 2 over 8. And actually negative 8. Okay. So that's just negative 1/4. And that would be your limit right there, guys. So basically that's what L'Hopital rule was, and that's how it's functioned, and that's what a limit was. Hopefully you guys don't fail. Remember, C's get degrees.